Hello students, how are you all? Good. Welcome to your own channel S2 classes. Today we are going to start the chapter called Haloalkanes and Haloarenes. Haloalkanes and Haloarenes. The name of this chapter is also known as Alkyl and Aryl Halide. Now, how I am proceeding with organic chemistry, I will tell you that how would I make the videos. In between that, we are proceeding with redox. I will complete all the concept, all the theory, all the questions regarding redox along with that. And in that haloalkanes and haloarenes, I will try to first complete all of the preparation of alkyl halide, preparation of aryl halide. In the next chapter, alcohol, phenol, ether, all the preparation of alkyl, aryl, alcohol, phenol, ether, carboxylic acid, aldehyde, ketone, amines. Then I will start all of the chemical properties, that is chemical properties of alkyl, aryl, everything. And along with that, I will complete your redox as well as your thermodynamics. So welcome to your own classes, S2 classes. And before starting the class, again one motivation line, that is every child is born genius. So don't treat yourself that student is topper, I am not that much good, that student is good, I am not that much good. If you do the hard work, you will become good, because every child is born genius. Now, after having all this bakwas, after having all these things, start the today class of preparation of alkyl halide from. Now alkyl halide can be prepared from the first one alkane, the first one alkane, the second one alkene. Preparation of alkyl halide from alkane, second one alkene, third one alcohol, fourth one halogen exchange method. So in today class, my target is to complete the preparation of alkyl halide from alkane, and the preparation inside this, there is a mechanism followed that is known as free radical mechanism. So in today class, I will complete the preparation of alkyl halide from alkane as well as the mechanism, that is free radical mechanism. So now welcome over here and see everything. First of all, whenever I start the chapter, it is written over here alkene. Now I will consider you that you didn't know anything about chemistry. From the scratch, from the beginning I will start. So everyone knows that the general formula for alkane is CnH2n plus 2. It means carbon has single bond in between. Carbon has single bond in between. Suppose I have written C1, so 1, 2 into 1, 2 plus 1, 4. So CH4 is the first member of alkane. This is the first member of alkane. And now I am going to do these things fast. Second one, we will have C2, so H became 6. C3, then H became 8. C4, then H became 10. Like that, we will write the all member of alkane started with CH4, C2H6, C3H7, C4H10, like that. And everyone knows that if there is one carbon, that is known as meth, 2 carbon, that is known as eth, 3 carbon, that is known as prop, 4 carbon, that is known as bute, 5 carbon, that is known as paint, 6 carbon, that is known as hex. Sir, we have studied these things in class 10th. Why you are revising it? Some of them has the problem. So it is a YouTube videos. I didn't know which one is aware of that, which one is not aware of that. In offline classes, so I will ask this. Do you know that? They will say yes. Then I will not dictate it. But over here, to whom I will ask? To you? Yes, sir. You are knowing this? Okay, then I will do it very fastly. Over here, 7 carbon, hept, 8 carbon, oct, 9 carbon, non, sorry, 10 carbon, dec. Now tell me, 11 carbon? Tell me. No, it, sir? I don't know. Undec. 12 carbon, do dec. Up to 12 carbon, if you are familiar, you didn't find any problem. In alkane, we are using the suffix. We are using the suffix as "ane." So if one carbon, it is known as meth, and suffix used as "ane" became methane. Similarly, 2 carbon became ethane. 3 carbon became propane. 4 carbon became butane. 5 carbon became pentane. 6 carbon became hexane. 7 carbon became heptane. 8 carbon became octane. 9 carbon became nonane. 10 carbon became decane. 11 carbon became undecane. 12 carbon became dodecane. So this is all about the things about alkane. This is alkane. Now we are going to start the preparation of alkyl halide from alkane. Can I erase all these things? Achha, one more thing you will already know, but I am just dictating, thinking that starting from 0. If it is CH4, it is known as methane. If we remove one hydrogen from it, it will become CH3, and it is known as methyl. It means this is alkane. Either it is methane, ethane, propane, butane, it is alkane. And alkane has a general formula CnH2n plus 2. And it is alkyl, that is alkane removal, one hydrogen from alkane became alkyl. And they have the general formula CnH2n plus 1. And suppose over here CH3, if you take C2H6, remove one hydrogen, became C2H5. So this is ethane, and this is known as ethyl. So whatever it is, ethyl, propyl, butyl, pentyl, hexyl, everything I will denote. If I am writing R, you will have to consider it is either ethyl, methyl, propyl, butyl, something like that. R means alkyl. R means alkyl. Over here, one more thing I will dictate in this place, that it is written preparation of alkyl halide from alkane. Alkane to we know, alkyl we know, halide. Halide means halogen family. It is halogen family, and halogen family is group 17 element. Halogen family is group 17 element, and what are the elements come inside? Fluorine, chlorine, bromine, iodine, instantine. And we will not have to discuss about instantine. We will have to discuss about fluorine, chlorine, bromine, and iodine. Fluorine, chlorine, bromine, that part little bit lighting come, but I am orally saying, I will try not to write over here. So fluorine, chlorine, bromine, iodine. So this is all about alkyl halide. It means if I am writing Rx, it is known as alkyl halide. R means alkyl, and alkyl should be anything, CH3 or C2H5 or C3H7 or C4H9, like that. And halide means either fluorine, chlorine, bromine, or iodine. And from alkane, it means overall. Written this part. If you want to take a screenshot, you can take it. Now we are going to prepare the alkyl halide from alkane. And before starting the preparation, I have told you little bit regarding alkane and little bit regarding alkyl halide. Now we are going to start the preparation of alkyl halide from alkane along with the free radical mechanism. Along with the free radical mechanism, so you will understand everything properly. Now, first of all, I have taken CH4 and try to react it with Cl2. So it in presence of H mu or sunlight or photon. This reaction happens in presence of sunlight, and the preparation of alkyl halide from alkane is also known as substitution. Is also known as substitution reaction. Oh sir, please see over here. Don't get distracted. Come. How would you know, sir? I said heart connection. Now prepare. This is known as substitution reaction. Preparation of alkyl halide from alkane. Sorry. In this, you will in this you will take CH4, Cl2 in presence of H mu, sunlight, photon. You will get over here CH3 Cl plus HCl. If you take over here CH4 plus Br2 in presence of H mu, sunlight or photon, you will get over here CH3Br plus HBr. If you take over here CH4 plus F2 in presence of H mu, sunlight or photon, it is going to be explosive. It means whenever you are reacting with this, there is no problem, reaction happens like this. But in this case, there is a explosive happens. And the last one we will have is CH4 plus I2 in presence of H mu, photon and sunlight. It is making CH3I plus HI, CH3I plus HI. But there is a problem arises. What is the problem arises? The problem arises over here. We are trying to do this reaction, we will get alkyl halide. We are trying to do this reaction, we will get alkyl bromide. We are trying to do this reaction, we will not get anything, explosion happens. But in this case, this reaction shifted backward. It means we are trying to react it with this, before becoming this compound, again returned back to this compound. It means we have facing the problem in producing methyl iodide, that is alkyl iodide. Why, sir? Because the byproduct over here we will get is HI. The byproduct we will get over here is HI, and HI is, it is very good reducing agent. It is very good reducing agent. What do you mean by reducing agent? Which reduces others and oxidized itself. Like LIC agent. LIC agent will do the LIC of other person, not their own. So similarly, it will reduces others and oxidize itself. And you know that reduction is losing of hydrogen, so it will lose the hydrogen and again come back to HI. So how can we do this reaction? So in this case, either you can use HNO3 or HiO4 or sorry, HiO3. If you use, it means over here you will have to use, over here you will have to use, 1 second. Oh sorry, marker has fallen down. Sorry. Over here you will have to use H mu, photon and sunlight. Over here you have to use H mu, photon and sunlight. Over here no reaction, but over here H mu, photon and sunlight as well as HNO3, HiO4 or HiO3. Why? Because these are very good oxidizing agent. And what is oxidizing agent? Which oxidizes others and reduced itself. Which oxidizes others and reduced itself. It means if you try to do this reaction like this in presence of H mu, photon and sunlight, the product will not you will get. But if you use HNO3, what happens? CH4 plus I2 in presence of H mu, photon or sunlight. H mu, photon or sunlight along with HNO3, HiO4, HiO3. Back portion visible? Yes, visible. Now it will going to produce CH3I, no problem. But HI is going to oxidized and became I2 plus H2O in presence of HNO3, HiO4, HiO3. It means this HNO3 will convert HI, either HNO3 or HiO4 or HiO3, convert HI into I2 plus H2O. It means HI say, I want to oxidize after reducing other. So HNO3 came and say, okay, no problem. Instead of oxidizing your own reaction, you can oxidize me. You can reduce me because I am an oxidizing agent, and HNO3 reduces to H2O and I2 will become. So it means whenever you have to do the reaction with chlorine, everything good in the presence of sunlight. Bromine, everything good. In case of fluorine and in the benzene diazonium salt, I have told you to prepare fluorine. Only two methods are there. One, a Bolz-Sisman reaction and another one Schwarz reaction. So over here fluorine can be explosive, not able to. In this case, in sunlight, photon and H mu to needed, as well as HNO3, HiO4 and HiO3 is also needed. Up to this, is there any problem? Write all the things that is written on the board fast. Write it. Written. Now in place of CH4, if they will give anything, suppose C3H8 react, so over here you will get C3H7Cl plus HCl, that's it. So I am taking one example, you can take any one of the example, written this part. Now we are going to see the mechanism that is involved in this reaction. So first we have seen the reaction, and in the reaction we have seen chlorine, no problem, bromine, no problem, fluorine, explosion, and iodine we will have to use HNO3 also, because Hi produced is very good reducing agent. Now the mechanism followed in this reaction is known as free radical mechanism. Free radical mechanism. Now, free radical mechanism. What is free radical mechanism? First understand. This is the mechanism in which you will get odd electron species. In which you will get odd electron species. What is odd electron species? Suppose we will have A and B. And if it will break like this, this is known as, suppose I have given you electronegativity of B is greater than electronegativity of A. So it will do heterolytic fission. Heterolytic fission or heterolytic cleavage. Heterolytic fission or heterolytic cleavage. Now over here you will get over here A plus and B minus. It has how many? 6 electrons. But this is not the condition of free radical. But in the free radical, suppose we will have A and over here B. Now over here it will break something like that. It will take their own electron and it will take their own electron, and because of that it will get A dot and it will get B dot. So it has 7 electron, and this is the only one species that has odd electron species. Over here, when it will take all the electron known as heterolytic fission, individual electron is known as homolytic fission. It means in free radical, first point odd electron species, second point it is homolytic fission. Third point, that where the free radical mechanism, how can we know that? Sir, how would you know that over here there is a free radical mechanism? So whenever there is helper, over there you can use free radical mechanism. What do you mean by H? H means heat. It means high temperature. If somewhere you are seeing that there is a high temperature given, over there you have to use free radical mechanism. E means electricity. Whenever there is electricity given, you have to consider that over here free radical mechanism. Whenever there is light given, or H mu given, or photon given, or sunlight given, if these things is given, over here you have to consider it as free radical mechanism, like that in this light given. P means peroxide. P means peroxide. Peroxide can be written directly as peroxide, or it is written as H2O2, or it is written as C6H5CO whole twice O2, or it is written as Kheras effect. If something like this written, you can say that over here there is a free radical mechanism follows. So whenever we are seeing about the preparation of alkyl halide from alkane, we are using H mu, photon and sunlight. It means this L is there, light, H mu, photon, sunlight, anything. It means it will follow free radical mechanism. Now in free radical mechanism, first odd electron species, second homolytic fission, third one peroxide, third one this happens only whenever there is heat, electricity, light, peroxide, and R means radical. If directly radical given like A dot, CH3 dot, Cl dot, some radical is given, it will also follow free radical mechanism. And the stability of free radical mechanism stability of free radical mechanism is 3 degree greater than 2 degree greater than 1 degree. Why, sir? Whenever I will dictate you GOC, you will come to know. Don't worry, just after sorry, just after completing all these things, we will start GOC. 3 radical, free radical means over here C, CS3, 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 and over here dot is there. Now this dot needs electron, and this CS3 will show plus I effect, and this will giving the electron to dot. So it is very happy. Detailing we will do whenever we are studying GOC, and trust me, 1 to 2 days I will upload GOC also. These are the important points regarding free radical. If you want to write, you can write it. Now I am going to erase this part. Can I erase it? Yes, okay. And I have little bit throat pain, so if I will doing like that at that time, very sorry for the inconvenience, because in the video it will become irritating type, but I don't want to just became late because of my throat pain. I can cope up with that, but in between the videos little bit cough, if you see, you will tolerate it, and thank you for your support. Now what happens in the free radical mechanism? Now suppose I have written one reaction CH4 plus Cl2 reacting in presence of H mu photon or sunlight. So it will form CH3 Cl plus HCl. Now we are going to see the one more thing. If you want, you can add it, that this is an industrial process. This is a industrial process. The production of alkyl halide is an industrial process. If you try to use this in laboratory, what happens? If you are taking CH4 plus Cl2 in presence of H mu photon or sunlight, and if you try to do it in laboratory, there is not lot of equipment, what happens? It will form CH3 Cl plus HCl. Again it will react, because if you take this much amount of Cl2, it means it has 1,000 crores of molecules. The another molecules react, became CH2 Cl2 plus HCl. Again it will react with Cl2, became CH Cl3 plus HCl. Again it will react with Cl2 and became CH CCl4 CCl4 plus HCl. It means this reaction is substitution reaction, and this reaction lasts up to which all the hydrogen cannot be removed and all the halogen will come. So if we will have to stop the reaction over here, so we will have to use this reaction in industries, because in industries there is lots of equipment that can stop the reaction in one step only. And now suppose we will have to produce methyl chloride, and in laboratory we are using, we will get carbon tetrachloride. We are never getting methyl chloride. So in laboratory it is not possible to do this reaction, because in this all the hydrogen remove, and in place of 4 hydrogen 4 chlorine will come directly, fastly, without anything. It will do and do up to the last. So it is an industrial process, that is not that much important, but I have dictated. I don't want to leave any points, so you will understand all the things and not feeling bored, sir. If you feel bored, stop. 5 minutes, go, have a tea, have a coffee, have a juice, have some fight with your brother or sister, have some talk with your mothers, and then come back. But don't feel bored. I am trying to make you understand all the things regarding organic chemistry very clearly and very properly. Now, this mechanism, suppose I have written this reaction and I have to write the mechanism of this reaction. So this mechanism follows 3 steps. The mechanism follows over here in 3 steps. Step number first. First step is known as chain initiation. First step is known as chain initiation. It means first Cl will come in presence of H mu photon or sunlight. All 3 are same thing. From the sunlight you will get an energy of H mu, and that H mu contains photon. So if it is written sunlight or photon or H mu, all 3 have the same meaning. It will do the homolytic fission. And you will get free radical over here. This is homolytic fission, cleavage. I have written all the things. Now you will have the step number 2. In the step number 2, it is known as chain propagation. in chain propagation, now CH4 will come. And CH4 is seeing Cl dot. Because of that, from here one hydrogen remove and HCl produce. And one hydrogen should be break like homolytic, means CH doing the homolytic fission, it will get dot, this dot is forming the bond, or over here you will get CH3Cl. Is there any problem up to that? Now you will get the third step. First step we will have chain initiation, second step we will have chain propagation. First step we will have chain initiation, chain propagation. Now in the second step you will get CH, not CH3Cl, CH3 dot. Understand what I am trying to say. First Cl will break, became Cl dot. Now CH4 will come, it will do the homolytic fission. This H and Cl will react and form HCl, and the remaining is CH3 and dot. So CH3 dot. And now this CH3 dot became unhappy. You have taken my one hydrogen. Then it will say, sir, another chlorine will come. Another chlorine will come. It will again do the homolytic fission, and the Cl dot will again react with this and forming CH3Cl plus. Again Cl dot will come. And now this step is going in a continuous process until and unless all the CH4 is converted into CH3Cl. Until and unless it will going to be happen like this, because if I am taking this amount of CH4 means crore of molecules, this amount of Cl2 means millions of molecules, all the molecules break and became CH3Cl and HCl until and unless this reaction going on. So I have written the arrow like this. In the third step, now we will come with the step number 3, and the third step is known as chain termination. The third step is known as chain termination. In the chain termination, you will have to check that how many dot you will get. One Cl dot you will get and one CH3 dot you will get. So we will write over here Cl dot comma CH3 dot. Is there any problem up to that? No, sir. Now what happens? This Cl dot react with this Cl dot and form Cl2. Now this CH3 dot react with Cl dot and form CH3Cl. And now this CH3 dot react with CH3 dot and you will get CH3 bonding CH3. It is also written as C2H6. It means Cl will react with himself, CH3 will react with himself, and both react together. After completing this all mechanism, first point what you will come to know that in the original reaction Cl2 is there, yes sir, there. CH3Cl is there, yes sir, CH3Cl is there. But this too I have not seen. But in the mechanism it is coming. It means while having this reaction in between, and that in between is known as intermediate. While in between, before forming CH3Cl, somewhat it has formed this product also. So this is known as intermediate product. So the intermediate product in this reaction is C2H6. Now understand the important point regarding this reaction. What are the important points? Suppose I am taking another marker. Suppose I have taken over here C2H6. Then over here Cl will do like this. In place of CH4 you will take C2H6. And this will become over here you will take C2H6, Cl dot should be as it is. Over here you will get C2H5 dot. Over here you will get C2H5 dot react and became C2H5Cl. Over here you will get what? Cl dot C2H5 dot. Again understand, not getting confused. This is the mechanism I have written whenever I am taking the reaction CH4 plus Cl2. If in place of CH4 it is C2H6, so what you will get over here? C2H6. Over here what you will get? C2H5, one hydrogen less dot. Over here C2H5 dot became C2H5Cl, and over here the product you will get Cl dot and C2H5 dot. If it is C3H7, then you will take everywhere where you have taken CH4, there you have to take C3H8 or H7, whatever it is. Getting my point? So this is all about the mechanism. Now the most important point you will have to understand regarding the intermediate product. Regarding the intermediate product. So whenever you are using this reaction, so the intermediate product is C2 H3CH3. If you see it properly, sir, see it, what you will get? CH4, one hydrogen less became double. If I have written the reaction C8H, 8 to just 16 to 18 plus Br2 in presence of H mu photon sunlight, we will get C8H17Br plus HBr. Now I am asking what is the intermediate product in this reaction. So what you will say? Sir, C over here, C8H18, so C8H17, C8H17. It means the intermediate product is C16H34. It means whatever be the thing over here written, wherever it is going to ask the question, first it will ask directly, second it will ask what is the intermediate product in this reaction. So if over here, sorry, C2H6, the intermediate product is C2H5, C2H5. If it is C3H7, C3H8, C3H8, what is the intermediate? C3H7, C3H7. It means whatever be the alkane group is there, one hydrogen less and double that. Suppose I have written C6H14 plus Cl2 in presence of H mu photon, and we will get C6H13Cl plus HCl. What is the intermediate? C over here, C6H14. It means it is going to become C6H13 and C6H13, that is C12H26. That's it. Getting my point? So these are the mechanisms. Sometimes they will ask what are the step sorry, what are the step involved in this reaction? So you will say first step chain initiation, second step chain propagation, third step chain termination. Then they are asking what is the intermediate product. So you will have to cross check that what is the alkane group. Just removing one hydrogen, double that alkane group is the intermediate product of this reaction. Write fast. More thing I have to elaborate over here. Write fast, fast, fast. Fast writing, sir. Written. Understanding what I am trying to say. Now, if not, then try to see the video one more times, so you will not get confused. Now, the last point regarding this. First we have seen the simple reaction, then we have seen, and the time is already how much? It is 32. So I will try to sum up within 15 to 20 minutes this topic. So I have taken individually the preparation of alkyl halide from alkane. Now, if the question will become like this: CH3, CH, CH3, CH2, CH3. Now it is saying what happens when it will react with, first point they have given, that what happens when the reaction is react with Br2 in presence of H mu photon or sunlight. Second they have given what happens when they will react with Cl2 H mu photon or sunlight. Third, they are asking that what happens when it reacts with I2 in presence of H mu photon or sunlight. But in the case of I2, you will have to not use only H mu photon sunlight, you have to use HNO3, HiO4 or HiO3 also, you know that. And in case of fluorine, to no reaction. Now in this case, what are the product you will get? You will get how many product? This, now previously we are using CH4, C2H6. So only one compound is there. Over here, this compound has a structure something like that, in which this is 1 degree, this is 2 degree, this is 3 degree, this is, this is 1 degree, this is 1 degree, and this is 3 degree. So one bromine will attack on 1 degree, one bromine will attack on 3 degree, and one bromine will attack on 2 degree. It means in this case you will get 3 product. 1 degree, 1 degree, 1 degree. So any one of the places bromine will attack, and you will get CH3, CH, CH3, CH2, CH2, Br plus HBr. Second product you will get CH3. This and these three are same. To any one of the places you will add Br. Second you will get CH3, CH, CH3, CH. Br will attack on 2 degree and CH3 plus HBr. Third you will get CH3, CH3 on 3 degree and CH2, CH3 plus HBr will come outside. Same thing you will get in the case of chlorine and same thing you will get in the case of iodine. In the case of chlorine, again you will get 3 products. You will get over here CH3, CH, CH3, CH2, CH2, over here Cl plus HCl. Second product you will get CH3, CH, CH3, CH, Cl plus CH3, over here HCl. Third product you will get CH3, C, CH3, Cl, CH2, CH3 plus HCl. In this case, again you will get the same product. This is the reagent for another one. In this case, again you will get CH3, CH, CH3, CH2, CH2I plus I2 plus H2. In this case, you will not get HI because HNO3 you are using. In this case, you will get CH3, CH, CH3, CH, I plus then CH3 plus I2 plus H2O. In this case, you will get CH3, CH, CH3, I, CH2, CH3 plus I2 plus H2O. Now in all of the cases you will get the same product. But in case of either bromine or iodine, you will have to take 3 degree as a major product and 1 degree as a minor product. If the answer you will get something like this, if anybody is asking which of the following is more quantity means major product, you will say, sir, this is 3 degree, so it is major product. This is 1 degree, so it is minor product. 2 degrees in between that major and minor. In this iodine case also 1 degree is minor product and a 3 degree is major product. But in the case of chlorine, you should have to be familiar with selectivity ratio. You should have to be familiar with selectivity ratio. You should have to be familiar with selectivity ratio. What is selectivity ratio? 3 degree has a value as 5, 2 degree has a value as 3.8 and 1 degree has a value as 1. What I am trying to say, board is visible up to that part. Yes sir, visible. I am saying that whenever you are reacting with bromine 3 degree, because their selectivity ratio, if you want to know in detail, I will tell you that part also. 3 degree, 2 degree and 1 degree. This is 1600, this is 400 and this is 1. There the difference in the selectivity ratio is too high that in bromine and iodine cases you will always get 3 degree as major and 1 degree as minor. But in the case of chlorine, sometimes you will get 3 degree major, sometimes you will get 1 degree major, sometimes you will get 2 degree major. You have to decide according to selectivity ratio. Now I will dictate how we will decide. First write all these things, and in case of bromine and iodine, closing the eyes, drawing the diagram and say 3 degree major, 1 degree minor, 2 degree in between that. Getting my point? But in case of chlorine, if you close the eyes and directly say 3 degree major, so sometimes you will get wrong answer. And IIT JEE is always targeting on that point where you will make mistakes. So I am just going to erase the about iodine and I will solve you how to find the selectivity ratio in case of chlorine. Can I erase that? Okay. So in the case of iodine and bromine, no problem. Product formed directly 3 degree major and 1 degree minor. But in case of chlorine, you will have to see the original structure, not the answer. In that, check over there how many hydrogen is there in 1 degree. Sir, 3, 3, 6, 3, 9 hydrogen. And what is the value of 1 degree? 1. So 9 into 1 is 9. How many hydrogen is there in 2 degrees? Sir, 2 hydrogen. And what is the value of hydrogen over here? 3.8 is 7.6. What is the number of hydrogen in 3 degree? So 1 hydrogen, sir. And what is the value over here? 5. You will get 5 over here. Now after this, you will have to check which value is greater. So this is greater. So in this case, 1 degree is going to be major and 3 degree is going to be minor. Getting my point? So it is not compulsory that 1 degree is always major. We'll have to check like this. Now some cases they will ask what is the percentage of amount of 1 degree produced in case of chlorine. You will have to write 9 upon 7.6 plus 9 plus 5 total into 100 and solve it. Whatever be the value you will get the exact value of the amount of 1 degree methyl means alkyl chloride is formed. Exact amount you will get. If you have to find the amount of 2 degree, what you will get? 7.6 upon 9 plus 7.6 plus 5 into 100. If you have to find the quantity or percentage of 3 degree, you will have to write 5 upon 9 plus 7.6 into plus 5 into 100. But if they are not asking percentage, just see which value is greater. This value is greater, so this is major. This value is smaller, so this is minor. And this is all about the preparation. From my side, I have tried very fastly and easily made you understand. First, take the screenshot, take it. Now, like this, I have completed all the things about the preparation of alkyl halide from alkane with free radical mechanism. And now I am going to start after this preparation of alkyl halide from alkane, alkene and alcohol as well as alkane to completed na, so alcohol, alkene and halogen exchange method all together in one video, because this is little bit larger, so I have taken this as individual. In the second video we will complete all the preparation of alkyl halide. So bye, have a nice evening, and if you like my videos then share with your friend and get good marks, and don't forget me as your teacher. Thank you, bye, have a nice evening, love you all.